Alright guys, in this video I'm going to be talking about the nomenclature of alkanes. I'm going to be going over all the rules that you need to know, and we're going to be doing the examples as we move along. You want to make sure you follow the rules one by one, otherwise you may get stuck in the naming or you may get the name wrong. So let's just jump right into it. So your first rule is going to be picking up the longest parent chain. Now, when you're picking up the longest parent chain, it doesn't really have to be going from left to right. It could be from top to bottom. Like for example, in this first question I have here, when I'm picking up my longest chain, I have two options. One of the options would be going from left all the way to the right. And when I do so, you want to count how many carbons you got there. Okay, so I got to 1, 2, 3, 4, 5, 6, 7. So it seems like I got 7 carbons in this longest chain. But then at the same time, I want to make sure I explore all the possibilities of picking the longest chain. And if I focus on the other one, what if I have this as my longest chain? Okay, so going all the way to the up now. And now when I count this as the longest chain, let's see how many carbons we got. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's going to have 8 carbons if we use the second chain that we just chose. So it's going to have 8 carbons. So your longest or your parent chain in this particular case is going to be the 8 carbons, not the 7 carbons. All right, so don't pick 7 carbons, it's going to be the 8 carbons. And anything else that's going to be coming out of the chain, for example, this particular one is going to be acting as a substituent. So we'll talk about that in a minute, but your first step is always going to be picking up the longest chain. So I do have 3 more examples here for you guys to make sure to pick the longest chain. So it's going to be a good idea to pause the session here and find out the longest chain in all those 3 examples. All right. Okay, so I assumed you paused the session and you did your work, and let's see if it matches with what I have here. So when I'm looking at my second example here, so one of the possibilities I get, so I'm just going to keep the same color there, is probably this right there. That's something that comes in your mind here, being the longest. If we pick this one, I got 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to have 8 carbons in this particular case. Okay, but what about if I pick something like going from the top, coming down, and then going to this way, basically. So if I choose this one, then the longest chain I'm going to have here would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm getting 9 carbons in that particular case. Okay, so that's going to be your longest chain, and want to make sure you go with the 9 carbons there, not with the 8 carbons. And what does that mean? The other side chains you got there, like this one right there and that one right there, they're going to be acting as your substituents in those cases. Okay, all right, what about this next one here? Okay, so I have one of the possibilities there is going to be going from left to right, so just like this. And maybe not all the way to the right, but coming down here is going to give you a longer chain than going straight to the right. And in this case, the number of carbons I have would be 1, 2, 3, 4, 5, 6, 7, 8 carbons. Okay, what about maybe another possibility where I go from the top and come down to the bottom? So let me change the color there. So 1, 2, so go down this way. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I get 10 carbons in this particular case. So this is the one that you actually want to go with. All right. So I'll talk about how you're going to be numbering those actually in a little bit. But for right now, the first step is going to be picking up the longest parent chain. What about this next one? Okay, well, next one seems like to be very straightforward. It's just going to have going from left to right. I don't really see any other options here. So just like that, and the number of carbons I got here, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 9 carbons in there. So hopefully you guys got the same numbers I have here, and if you have troubles um, looking at those, you may want to rewatch this section of the video before you proceed. Okay, so obviously, depending on how many carbons you have in the parent chain, your name is going to end up with these suffixes here. So if you have, let's say, in the first one you have 8 carbons, so your name at the end of the day is going to end up with octane. If you have 9 carbons, it's going to end up with nonane. And if you have, let's say, 4 carbons, it's going to end up with butane. So you want to make sure you're aware of these suffixes depending on the number of carbons you're going to have in the main chain. Okay, well, that's your first step, identifying the longest chain. Once you've done so, you move on to the next step where you're going to be counting the side chains. You're going to be counting your parent chain, and there are usually going to be a couple of ways you can do so. So let's suppose these are the same example that I have up there. So we did figure out the longest chain in this particular one. So that was the longest chain. All right. Now, when it comes to counting, either you can count it from one end or you can count it from the other end. So you have to be really careful with which end you really pick. So let me give an example in this particular case. If I do count it from the left side, it's going to be 1, 2, 3, 4, 5, 6, 7, and 8. And then if I count it from the right side, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. And your tendency is going to be you want to make sure you start from the side where your substituent on the chain gets the lowest number possible. So in this particular case, if I count it from the right side, then my substituent's getting a number 3 here. And if I count it from the left side, then your substituent's getting number 6. So you actually want to count it from the right side. So this is the correct way of counting it. So you want to go from right to left in this particular case. Okay, and then you also want to identify what your side chain going to be in this particular case, or the substituent's going to be. Now, I have only 1 carbon in this particular substituent, so that's just going to be 1 carbon, and if you have 1 carbon, it's going to be called methyl. So remember, the suffix still stays the same. It's going to be meth, and then the substituents are going to end up with YL, so it's going to be called methyl. All right, so I have a methyl at the 3rd position, so this particular one is going to be called a methyl. Okay, well, let's look at what if you have more than 1 substituent present in the chain. Okay, and that's going to be the same example that we got up there, and we did figure out the longest chain in this particular case, and we said it would have been going from the top, going to the right, and then going to the bottom, just like this. Now, there are obviously going to be 2 ways of counting it. You can count it from the top to the bottom or bottom to the top. So let's suppose if I count it from the top, then it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we got 10 carbons in that case. And then if I count it from the other way, it's going to be 1, 2, 3, 4, 5, and then I got 6, 7, 8, 9, and 10. Now, which one is actually going to be the right way? You always want to make sure your substituent, your first substituent, gets the lowest number possible. So if I go from top to the bottom, which is expressed in this yellow numbering, then your first substituent comes on to the 4th carbon. All right, that's going to be your methyl. But if I count it from the bottom, that's shown by this orange color numbering, then your first substituent comes on carbon number 3. And since it comes from it gets the lower number when you count it from the bottom, this is going to be the correct way of numbering this chain, not by the yellow colors. All right, so go with, I would say, bottom to top in terms of numbering for this particular chain. Okay, and then be able to identify your substituents. Okay, so on the third position, and I can go ahead and probably erase the other one actually, since we don't need that one. Okay, so then I can say I got a methyl group on the third position. So be able to identify your groups there. What's the group going to be on the fourth position? Well, it's got two carbons, and if you have two carbons, it's going to be an ethyl group. Okay, and then on the fifth position, I got another methyl, and on the seventh position, I got another methyl there. Okay, so you want to make sure you have your all the substituents identified, and after that, it's just going to be about putting them together in terms of the names, and I'll talk about that in a minute. What about this next one? Suppose you have obviously more than one substituent, and both ends gets the same numbers. If you count from the right side or the left side, so like in this particular case, if I count it from the left side, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then if I count it from the right side, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, you can clearly see when you go from either the right side or the left side, your first substituent is going to be coming at number 2. So when you're going from the left side, you're getting chlorine on number 2. When you're coming from the right side, you're getting this methyl on number 2. So if there is a tie, then you look at the next one that's going to break the tie. So in the next case, I have a bromine on number 3 when you're counting from the right side, but when I look from the left side, you have this this big group right there that's going to be on carbon number 4. So since your bromine gets the lower number in this particular case, you're going to have to count it from the right to the left and not from left to right. So your correct way of counting is going to be from right to left. So I can probably go ahead and erase the incorrect way of numbering it so that we just focusing on the one of them. And then let's just be able to identify all the functional groups. So we got the methyl here on the second position. I got this bromine. So if you have a bromine, it's going to be called bromo. So I got those written down on the right side there. And then I got this Cl, that's going to be called chloro. And I got this 3-carbon group right there. And some of them is going to have a special name. So I'm going to talk about those here as well. So let's say on this here, this pink lines are going to be your parent chain or the main chain, okay? And then you got these different number of carbons with different ways attaching to the main parent chain. So you want to make sure you know how to kind of name those. So if you have 3 carbons, so you got 3 carbons attached to the main chain. So if you go back there, what's that going to be called? With 3 carbons and it's in a long chain, it's going to be called propyl. So this particular group here is going to be called propyl. Okay, and then let's look at the second one here. When you look at the second one, the number of carbons is still going to be 3. It's 1, 2, 3. So it's still going to be propyl, but the connectivity is different here. So you can't really call it propyl because otherwise there would not be any difference between this first one and second one. And as a result, this one is going to be called an isopropyl. Okay. Now, what about this next one here? How many carbons we got here? We got 1, 2, 3, 4. So this one is going to be called butyl. Because remember, if I go back here, 4 carbons is going to be butyl, 5 carbons is going to be pentyl, 6 carbons is going to be hexyl, and so on. What about this next one here? So figure out how many carbons we got total on that side chain. That's 1, 2, 3, 4. So still got 4 carbons. So it's going to be some sort of butyl, but I cannot just call it butyl. Otherwise, it would not have any difference between this previous one. So as a result, this one is called an sec butyl because it's attached to the second carbon. So that's how you want to memorize it. So it's called a secondary butyl. This next one, let's see, we got 1, 2, and 3, 4. 4 carbons again, so it's going to be butyl as well. But instead of just calling butyl, just how it's connected to the main chain here, it's going to be called an isobutyl. Okay. What about this last one here? This last one is going to be, again, 4 carbons. I can say 1, 2, 3, 4. And that's going to be called tert-butyl, just because how it's connected. So you guys want to make sure you're able to identify what type of substituents are attached to your main chain. So if I go back here, and remember we're talking about this little bit bigger group here, and we didn't know what this would be called, but now we know if you have 3 carbons and the second carbon is attached to the main chain, it's going to be called an isopropyl. Okay, so that's how you're going to be numbering those, and that's how you're going to be identifying your side chains or the side groups there. Let's go and talk about this next one here. What if there is a tie altogether? Like, you know, in the previous cases, we were able to break the tie by looking into the next group, next substituent. But what if there is a tie? Like in this particular case, I have 1, 2, 3, 4, 5, and 6. That's one way of counting it. And then the second way of counting it would be starting from the right side, 1, 2, 3, 4, 5, and 6. And in either case, you're getting the second, your first substituent is going to be on the second position. So that means you got to look for a tie there. And the tie in that particular case is going to be going with alphabetical order. So then you look for your substituents. So one of the substituents is going to be methyl, and your other substituents is going to be bromo. So B comes before the methyl, and since B comes before methyl, we're going to have to start numbering it from the left side because bromine is going to get the priority in that case here. So I'll go ahead and erase the incorrect one. Now, let's try to put it together in terms of the naming now. And when you have multiple prefixes, like multiple substituents, you can use di, tri, tetra, penta, and stuff like those. And in this particular case, I have the bromine and I got the methyl. All right, so since I have only 2 substituents and I want to put those in alphabetical order, so I'll start with the bromo first. So it's going to be 2 bromo dash, and then your second substituent is the methyl here, and you want to make sure you specify the position of the methyl on that chain. So it's attached to the 5th carbon, so it's going to be 5 methyl. Okay, and then your parent chain is 6 carbons long. So what's going to be the suffix for 6 carbon? Well, it's going to be hexane. So it's going to be 2 methyl hexane there. So that's how you're going to be naming this. If you do have multiple substituents where you're going to be using di, tri, tetra, then you're not looking at the prefixes for the alphabetical order. All right, so you arrange all the prefixes when it comes to arranging your substituents in the alphabetical order, except if you have iso. Okay, except if you have iso. So there's if you have, I'm just going to erase this part right there. I'll accept if you have cyclo, isopropyl, isobutyl. All right, so those 3 do follow the alphabetical order. So if I want to go back and try to name this particular one, so let me just copy this down here. And I can bring this down here to name it. Okay, so I know what my substituents are. So I got a methyl on the second position, I got a bromo on the third position, and I got a chloro, and then I got an iso. Make sure you put those in the alphabetical order. So your bromo is going to come first. So I got 3 bromo. And then after bromo, you're going to have chloro. So it's going to be 8 chloro. After chloro, now you got methyl and isopropyl left. So remember, in isopropyl, I do count in the alphabetical order. So it's going to be 6 isopropyl. All right, so the name is getting longer, so I'll just write that on the second line there. And then after that, on the second position, I got the methyl, so it's going to be 2 methyl, and then it's just going to be 9 carbons in the chain, so it's going to be nonane. Okay, so that's how you're going to be naming this. Let's go back and try to get the other one copied down. So we got down here. Okay, so I know all my substituents, and in this case I do have actually 3 methyls, all right, and I got a ethyl group. So since I have 3 methyls, and I'm gonna put tri for the 3 methyls, but remember the T doesn't count in the alphabetical order, all right, so I'm gonna be looking at the M here, and I'm gonna be looking at the E. So between the M and E, E comes first, so I would have to say 4 ethyl. And then I have 3 positions where you got the methyl, so you want to make sure you specify those positions. So you got the carbon number 3, carbon number 5, and carbon number 7 where you got the methyls. So I'm going to say trimethyl. And then you have a total of 10 carbons there, so it's going to be decane. All right, so make sure your only first letter is going to be uppercase, the rest of them just going to be lower cases. So that's the overall rule you have for naming alkanes. Occasionally, what you're going to be seeing is you have multiple parent chains with equal lengths. So let's look at, let's break that down. What if you have a compound that's got multiple parent chain and that has the same length? For example, if I look at this particular question here, so I can see this is going to be one of your chains, all right, and then I can say the other chain would be going straight from left to right or right to left, and in both cases you get the same number of carbons. So if you do have the same number of carbons in multiple and you have multiple chains, you want to go with this order. So look for the greatest number of side chains. So you want to pick the parent chain that gives you the greatest number of side chain. And if that doesn't work, then you move on to the next one, substituents that give you the lowest number. So this is going to be in an order here. But seems like your first one will make a difference here. And we're going to have, if I count it from the left to right, it's going to be 1, 2, 3, 4, 5, 6, and 7. And you can clearly see you get only one substituent in that case. All right. However, so I'm just going to take that out. However, if you take the other parent chain, it's going to be 1, 2, 3, 4, 5, 6, and 7. So when you do so, you get a substituent on the second carbon, and then you get a substituent on the third carbon. And the rule is you want to make sure you pick the parent chain that gives you the maximum number of side chains. All right, so you want to go with this orange color there. And if that doesn't help, then you look at the second one. You want to have the substituents that gives you the lowest numbers. If that doesn't help, then you want to make sure you have the greatest number of carbons in the smaller side chain. So you want to just go in that particular order. So now I know how it's going to be named, how it's going to be numbered, and which chain I'm going to be picking here. So I'm going to erase those part right there. And let's see now. I got a methyl group on the second carbon, and I got a ethyl group on the third carbon. So those are the only two you have to worry about. Since E comes before M, so I would go ahead and write down 3 ethyl, and then I'm going to have on the second position I got methyl, and then you got 7 carbons in the main chain, so your suffix is going to be heptane. That's going to be your parent chain in that particular case. All right, so hopefully this was helpful. If you have any questions regarding naming the alkanes or even regarding the rules, please feel free to leave the comments in the section below.